Right, we just want to talk a little bit about our imaginary numbers. So we have to recognize that the formal definition of the imaginary numbers is I squared equals negative 1. So we have to recognize that that's the formal definition of I squared. And so I equals the square root of negative 1. And since I equals the square root of negative 1, then we can use that in lots of different calculations. So what we've got to be able to do is evaluate all i's so that we've reduced it down to their lowest value. So what I mean by that is we never carry an exponent with our I because we can always evaluate it to something else. So let's just take a look at that real quick. So as we said, I squared equals negative 1. I to the third is actually the same thing as I squared times I. Well, since we already said that I squared is negative 1, we can substitute negative 1 for I squared, and so we would end up with negative 1 times I, which just gives us negative I. Okay, then we also have I to the fourth, and I to the fourth is the same thing as I squared times I squared, and we already know that I squared is equal to negative 1, so we have negative 1 times negative 1 equals positive 1. Okay, so so up here we also want to say that I is just equal to I. Alright, so we have I to the first power, and then we have I to the second power, and I to the third power, and I to the fourth power. Okay, so we have all of these different powers here, and these are all that we have to worry about because we went from positive I to negative 1 to negative I to positive 1. And those are the only values that we can have when we're dealing with I. Okay, so I moved those off a little bit and I just rewrote them so that it was easier for us to just see it all at one time. So these are the only 4 values that you can have for I values. You can either have I, negative 1, negative I, or positive 1. And so if you look at those, you'll notice that the exponents will help us out a lot. Because every time you have an odd exponent, your 1 and your 3, you have an I. Okay? Every time you have an even exponent, the 2 and the 4, you have a 1 or a negative 1 in your answer. Okay, so we need to use that kind of information to make it easy for us to decide what the evaluated value is going to be when we have I raised to a power. So if we had I raised to the 7th power, that's the same thing as saying I to the 6th times I. Well, we know that I to the first power is just I. So now we have to figure out what I to the 6th power is. So I to the 6th power is just I times I times I times I times I times I. Okay, so we know that I times I is I squared. And here we have I squared, and here we have I squared. Now we have those things figured out. Well, this is just I to the 4th, which we know equals 1. And then we still have an I squared, and I squared equals negative 1. So we have I to the 4th, which is 1, times I squared, which is negative 1. So all of this I to the 6th equals negative 1. So that whole thing equals negative 1, and then we multiply by I, so I to the 7th just equals negative I. All right, let's try another one. So we have I to the 5th power. Okay, so I to the 5th power is the same thing as I to the 4th power times I. Now I'm separating out that odd exponent. I'm trying to make this odd exponent be even because the odd ones always had an I in the answer. And I can see that because when I pull out that extra I, it's still there. And now I know I to the 4th has a value with a 1 in it because all of the even numbered exponents have 1s in them. So I to the 4th, we saw over here, is equal to 1. So this equals 1 times the I that we pulled out times I. So this equals simply I. All right, so let's organize everything that we know so far on the the odd exponents. So we have I equals I. So I to the 1 equals I. I to the 3rd equals negative I. We have that over here. Okay, we just discovered I to the 5th equals I. And I to the 7th, we saw just a minute ago, equals negative I. So you'll notice the pattern. Every other odd number is just the opposite sign. So odd numbers always have an I, and it goes from a positive I, to a negative I, to a positive I, to a negative I. And it just keeps going down that way. Okay? So similarly, we have the same thing with our positive exponents, or excuse me, not our positive exponents, our even exponents, in that we have I squared equals negative 1, I to the 4th equals positive 1, I to the 6th, if we worked it out, would be negative 1, I to the 8th, if we worked it out, would be positive 1, and so forth. So starting with I squared being negative 1, every next even number is going to change sign. So it's going to go negative, positive, negative, positive. Just like over here, it went positive, negative, positive, negative. Okay, so when we get up to the really large numbers, that's when it gets a little bit more complicated. So here on these numbers, they're pretty small, and so we can easily figure that stuff out. So when we get really large numbers, that makes it a little bit more difficult. But we can certainly see this pattern that every time we have an exponent that's divisible by 4, we get a positive 1. When we have an exponent that's only divisible by 2 and not divisible by 4, we get a negative 1. Okay? So therefore, and excuse me, also we have all of our odd exponents always have an I in them. Okay? So now let's take a look at just simplifying based off of the exponent. So if I had I to the 13th, okay, I want it to be positive. I want to work with a positive number. So I'm going to change I to the 13th to be I to the 12th times I. And we know that 13, since it's an odd number, is going to have an I in the answer. And there's that I. So we're just going to pull it down here. Now we need to figure out, is it going to be positive or negative? Well, we can tell that because of all of this information here. All of that information helps us figure out whether I to the 12th is going to be positive 1 or negative 1. Since 12 is divisible by 4, 12 is divisible by 4, it's going to be, we can rewrite I to the 12th as being I to the 4th times I to the 4th, times I to the 4th, and because I to the fourth times I to the fourth times I to the fourth is the same thing as I to the 12th. I to the fourth equals 1. I to the fourth equals 1. And I to the fourth equals 1. So 1 times 1 times 1 just gives me a 1. So I'm going to have 1 times the I that was left over. So I to the 13th is going to be positive, I to the 13th equals positive I. And if we were to go through our jumps over here, I to the 7th is negative I to the 9th would be positive I to the 9th is positive I to the 11th would be negative I, so therefore I to the 13th is going to be positive I. So every other, as you jump your odd numbers, the sign of I changes. Just like as you jump your even numbers, the sign of 1 changes. Okay, let's try 2 more problems, and hopefully this will clear things up a little bit. So we're going to do I to the 27th. Okay, so I to the 27th, that's an odd number. Therefore, the exponent is an odd, so we know we're going to have I in our answer. So let's go ahead and simplify this to be I to the 26th times I. Okay, so now this is going to turn into because it's an even exponent, it's either going to be a positive 1 or a negative 1. And we can determine that based on whether or not it's divisible by 4. The exponent is divisible by 4. So since 26 is not evenly divisible by 4, it can't be a positive 1, so it has to be a negative 1. So I to the 26th equals negative 1 times the I that we pulled out gives us a negative I. Okay, and our last one that we're going to do, I to the 37th. Okay, so I to the 37th is an odd number, therefore it's going to have an I in it. So we're going to pull out that I, and so we have I to the 36th times I. So there's the I that we pulled out. Okay, I to the 36th is going to either be a negative 1 or a positive 1. So it's going to be a positive 1 if the exponent is divisible by 4. 36 is divisible by 4, so I to the 36 is actually equal to a positive 1 times this I, so we end up with a positive I.